M1 Dynamics example 21. We've got two particles here of masses 2 and 4 that are moving towards each other along the same straight line. So a particle of mass 2 and a particle of mass 4. It says that the particles collide, and before the collision the speeds of A and B are 3 and 2 respectively. That means in that order. So we've got 3. Now they're moving towards each other, so that 2 must be moving towards the left like that. So make sure you read the question carefully. After the collision, the direction of motion of A is reversed, so it's bouncing off, and its speed is 2. We don't know what happens with this one, so it doesn't really matter which way you put your velocity arrow on this one. I tend to just keep it going in the same direction as I'm taking as positive. So I'm taking to the right as positive. So we've got to find the speed and direction of B after the collision. Again, using conservation of momentum, we have a mass of 2 with a velocity of 3 and a mass of 4 with a velocity of -2. Remember, that's going to the left. So that's before the collision. Then after the collision, we've got the mass of 2 is going with a velocity of -2 because it's towards the left. And the mass of 4 has a velocity of v, which is what we're trying to find. So if we do the calculations there, we're going to have 6 minus 8 on the left-hand side. And then on the right-hand side, we'll have -4 plus 4v. So 6 take 8 is -2 equals -4 plus 4v. Bring the 4 over, 2 equals 4v, and so v equals 0.5. So what that tells us is that B has velocity 0.5 meters per second in the original direction of A, in other words, to the right. So in the original direction of A, i.e. to the right. You could also say that B is reverse direction and it's going the opposite way to the way it was to start with. So the fact that this V is worked out to be positive and we were taking positive to mean towards the right, it means that this particle is going the same way that A was originally, or you could say it's been reversed in direction from what particle B was originally, either way. Okay, part B, we've got to find the magnitude of the impulse given by A to B. So the impulse given by A to B. So it doesn't really matter which one you do because A and B will have an equal and opposite impulse. So whichever way is fine, it doesn't really matter. I'll do it for B. So the impulse, we know it was travelling to the left and now it's travelling to the right. So it must have had an impulse that way to the right. And so the impulse we know is given by mv minus mu. So impulse is equal to 4v, that's 4 times a half, minus 4 times u, which was -2. So if you work that out, 4 times a half is 2. We're subtracting -8, so that's +8. And so the impulse is 10 Newton seconds.